Let's talk about the different methods for collecting samples. We're going to have 5 different types, and we're just going to go through this chart. It's going to be really straightforward. What we're going to do in this box is basically like draw little random pictures. Well, not random, we will on this one. But we're going to draw pictures that will help us visualize what's happening. So here it goes. Simple random sampling. All objects in the population have an equal chance of being in the sample. So the names of 20 teachers are chosen at random from all 110 teachers at the school. So they're just going to pick, doesn't matter how many men they pick, women they pick, math teachers, English, doesn't matter. They're just going to randomly pick it. So keeping in mind that this box is going to represent all the teachers at the school, we're going to pick just randomly. There we go. We're just randomly picking, just random. There we go. Whoa, those two are close together. And these are next door. And then that guy's in the corner, random. Quite random. How many did I pick? It doesn't matter. It doesn't have to be that example. Okay? Stratified, a little bit different. This one gets a little confusing sometimes and mixed up with cluster sampling. I'll make a distinction between the two. The population is broken into non-overlapping groups, then a sample from each group is taken. So just for example, if I wanted to split up this into 2 separate groups. So here's the population of whatever we're studying, like people in Asheboro. I would split that population there. We're going to have non-overlapping groups. We're going to have that, we're going to have that, we're going to have 3. We're going to have 3 different groups. So there are, let's see. There are going to be kids and teenagers. There's going to be people that are in their 20s through 60s, and there's going to be like people 70 and up. Non-overlapping groups. You can't be a teenager and in your 70s. It's not going to happen. So we have, in this case, 3 different situations, okay? The proportion of the sample is the same as the proportion of the group to the population. We're going to take a sample from each group. Okay, let's make this a little more clear. Not using this example. In a class of 15 boys and 10 girls, 1 out of every 5 boys is chosen, and 1 out of every 5 girls is chosen. So they're going to pick a proportion from the population. So let's suppose that we're going to pick 1, 2, 3, 4 people that are in the 70 and older. We're also going to randomly pick, I would say 4, but this looks like it's bigger than 4. Like if I can fit 4 in this group, then I'd be able to fit, I don't know, maybe 20 in this group. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay? And then here, looks like I could fit, if I had 4 in this little skinny group, it's probably about 3 times as big. So we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I think they're spread out about the same, but we're going to pick some from each group. So based on this example, we've got kids and teenagers. We picked 15 of them. We had 20 people from their 20s to their 60s, and then 70 and up, we picked 4 people, but it was proportional to the population. All right, convenient sampling. Collect data without systematic randomization. So a surveyor asks questions of everyone that goes into a store. This one's going to be really easy to draw. You walk into a store, I want to ask you a question. You walk into a store. I want to collect data about how people in Asheboro feel about something. I walk down one street and do it. That's convenient. It's probably going to be very biased because people on one street might all feel the same way about a certain issue. Okay? Or if I want to survey or ask questions of everyone that goes into a store. If I say, hey, do you like this store? Probably yes, because they're going in the store. Okay? People that don't go into the store, not going to like the store. Systematic. All right. Items are chosen from a population according to a fixed rule, for example. Every 20th person on a list is asked a series of questions. This is where they want to know how you feel about the next presidential election, and they have a telephone book. It's a thing we used to have when people had telephones, not there were cell phones. And they would pick like every 5th person, and they'd call them. So very systematic, every 5th person, or every 20th person, or something like that. Very systematic. Every other person on the street. Oops, missed one. They didn't answer their survey. There we go. Okay, this one is, again, easily confused with stratified sampling. Population is broken down into many different clusters. A random selection of clusters is chosen, and within each, a random sample is done. So what I'm going to do in this one is I'm going to split it up into different clusters, and mine are going to look equal. They don't necessarily have to. So the residents of a few random cities are chosen for a survey that will represent the entire state. So they pick four different cities from the state, and they choose a few people from those cities. So out of this population, entire population represented here, I'm going to pick a few people randomly out of this one, a few people randomly out of this one, and a few people randomly out of this one. Not those two. Why not? I don't know. Okay, the main difference, and this is going to come out in the next video more, the main difference between stratified and cluster sampling is this is going to be sum of all of them. I took some of the kids and teenagers, I took some of the 20 to 60-year-olds, I took some of the 70 and up. And this is going to be sum of some of them. I broke it up into 5 groups. I took some of these, some of these, some of these, not those, not those.